Welcome to AI Podcast. I'm Ethan, and today we're digging into Toolscaler from EMNLP's Findings 2025. It's about making language models way better at picking and using tools at large scale.
And by large scale, you mean not a handful of plugins, but like a small city of APIs, right?
Exactly, tens of thousands of tools. The headline is simple. Instead of giving each tool its own special ID token, Toolscaler gives every tool a short little code made of shared pieces. The model learns to generate that code and then fill in the tool's parameters. That shift is what lets it scale and generalize.
So the model stops memorizing one giant phone book and starts speaking a compact code language about tools. Who's behind this?
The paper is led by Yunyue with colleagues, including Liang Wang. They're affiliated with the Institute of Automation at the Chinese Academy of Sciences and collaborators in industry.
Got it. Before we go deeper, why do we need this? I mean, tool use has been a thing for a while.
Right. The standard playbook hits limits. One approach is retrieval in the prompt. You fetch likely tools and stuff their docs into the context. That's brittle and costly, and the model can only see as many tools as the context allows. The other is baking tools into the model by adding a unique token per tool. That makes the vocabulary balloon, and each tool embedding becomes a little island with no sharing. Add 10,000 tools, you add 10,000 tokens.
Which is like giving every screwdriver on Earth a brand new word instead of saying Phillips or flathead. Zero sharing.
Perfect analogy. Toolscaler says, let's tokenize tools semantically. Think of a tool's identity as a short zip code. Similar tools share digits. When the model picks a tool, it generates the zip code, not a one-off word it had to memorize.
Okay, but where do those digits come from? Who decides the code pieces?
The authors learn them. They embed tools using their descriptions and usage signals, then cluster those embeddings into a multi-layer codebook. Each tool gets a sequence like building with Lego bricks. Because the bricks are reusable, new tools can reuse old bricks. That's the structure-aware part.
So the codebook is like a parts bin. Instead of inventing a new part every time, you snap together existing pieces. Why should that make the model better at actually calling the tool?
Two reasons. First, retrieval becomes generation. The same model that answers your question can generate the code for the best tool, which keeps the process end-to-end. Second, because similar tools share bricks, the model can generalize. If it has never seen a brand new weather API, it might still get the code mostly right because it shares most of its bricks with other weather tools.
I like that. It sounds a bit like using phonemes in language, right? You can say new words because you reuse sounds you already know.
Exactly, and the training reflects that. They do it in stages. Start by learning the codebook and initial codes. Then fine-tune the language model to both predict the right code and to produce the actual tool call with parameters. Later, they loop back, adjust the codebook using downstream signals, and fine-tune again. It's like iterating between learning the alphabet and practicing words.
Walk me through the experiments. What did they test on?
They use Toolbench, which is like an app store of real web APIs. Imagine a giant shelf of categories: travel, finance, sports, mapping, that kind of thing. They evaluate two things. One, how well the model retrieves the right tool or set of tools for a query. Two, once it picks a tool, how often it actually gets the call right and produces a good final answer.
And they compare against what? A classic retriever and other generative systems?
Yes, baselines include traditional retrieval, embedding-based methods, and a strong generative baseline that tries to call tools directly. Toolscaler consistently edges them out on ranking the right tools and on the downstream success rate when the tool is actually called.
Did they try scenarios with more than one tool per task?
They did. Single tool tasks are easier. Multi-tool tasks are where this design shines because the shared code pieces help the model navigate categories and pick sequences of tools that fit together. The gains are most visible there.
How about unseen tools? Because in real life, new APIs launch every week.
That's a key point. Because the representation shares bricks, the model isn't starting from zero when a new tool shows up. The paper reports better generalization to tools the model didn't see during training compared to the one token per tool approach.
I'm curious about inference. If the model is generating these codes, how do they prevent it from hallucinating an invalid code?
They constrain decoding. Think of it like guardrails in a bowling alley. The search only explores valid paths in the codebook, so the model stays on the rails of real tool identities.
Nice, but there's always a catch. What are the limitations they acknowledge?
A few. First, it still depends on decent tool descriptions. If the documentation is thin or inconsistent, the learned codes can be shaky. Second, updating the catalog isn't a magic zero-cost operation. Adding or retiring tools requires refreshing the codebook and doing some fine-tuning. Third, the way they evaluate final answers sometimes relies on a model-based judge, which can introduce bias about style or format.
And compute?
Reasonable but not trivial. It's multi-stage training, and while they show it working on commonly used open models, you still need a solid setup to reproduce the pipeline end-to-end.
Let's make this concrete with an example. Say I ask, book me a flight to Tokyo, and then show me the weather for the arrival day. How does Toolscaler help?
Great example. The model first predicts a short code for a flight search and booking tool. Because many travel tools share a few code pieces, it can pick a good one even if this exact tool is new. It fills parameters like origin, destination, and dates. Then it predicts a code for a weather tool and carries the arrival date into that call. Because those two tools live in related neighborhoods in the codebook, the model treats them like adjacent stops on a subway line instead of random pins on a map.
That adjacency picture helps. It's not just a bag of tools, it's a map with districts and streets, and tools that live near each other share street names in their codes.
Yep, and that spatial structure is what scales. Instead of linear growth in vocabulary with every new tool, you reuse the same code pieces. The capacity grows roughly with combinations of those pieces.
Do you think this replaces retrieval in practice, or is it a hybrid story?
I see it as a strong push toward generative first tool selection. In production, you might still mix in a light retriever for safety or latency, but the core insight is that the model can learn a compact language of tools and speak it fluently.
If you were to poke at future work, what would you ask for?
Live updates. Imagine a streaming or on-device way to refresh the codebook without heavy retraining, like hot swapping a new tool into the map. I'd also like more robust evaluators for execution quality, ideally task-specific checks or human audits. And I'd test beyond web APIs, say local functions or robotic skills to see if the same code language carries over.
I'd add safety. If the tool catalog includes actions that can spend money or change data, the model needs tripwires. Knowing the code for a tool is great, but we also need policies that say when not to use it.
Totally. Guardrails around permissioning and intent classification would fit nicely next to the codebook idea.
Quick note on authors again. You mentioned Yunyue Su and Liang Wang. It's always nice to credit the team doing the heavy lifting, especially when they also release artifacts that others can build on.
Absolutely. The paper is clear and practical enough that teams can try it on their own catalogs if they have tool descriptions and usage traces.
All right, let's land this. What's the one-sentence takeaway for folks listening on their commute?
Toolscaler shows that if you treat tools like words made of shared sounds rather than isolated tokens, one language model can both find and use a huge catalog of tools more accurately and more flexibly.
And from me, think of it as giving your model a map of the tool universe, not just a list. With that map, it travels faster, makes smarter connections, and handles new neighborhoods without getting lost.
That's our show. If you're building agents that juggle many tools, Toolscaler is worth a close read and a weekend experiment.
Coffee and clustering. Thanks for listening to AI Podcast. See you next time.